Hello everyone, this is Mukundan Raghavan, and in this video we are going to cover the Apache Spark Architecture. In previous video we have seen the introduction about the Apache Spark and PySpark. It's very essential to understand the architecture for the coming sessions, and in this video we will try to understand the main components of the Apache Spark. The first and foremost is driver program. This is like a manager for your entire operation or for your application. Basically, you are going to give the problem statement or a set of instructions that has to be done through Spark. So it will have your main code, and also it creates the task for you. You might have the bigger problem, then you will divide that into the small tasks, which are designed for the individual workers. We will see what is worker in some time, but let's say you will just split your main task into small tasks. Then you need to give to the different workers, then you need to coordinate. So basically, this driver program will be driving your entire application or your problem statement. And also it has the Spark context and task scheduler. By the name, you can understand task scheduler is nothing but scheduling the task. And Spark context is the place where you will have the important information. We will see in some time what are those information. Next one, cluster manager. Cluster manager can be considered as a resource allocator. When you give some task, you need to have the resources to do that. So cluster manager will be taking care of that resources. Basically, it is a different systems. These systems will be called as worker nodes. So cluster manager is just giving the different resources to you as per your requirement. Here, you can have the different types of cluster manager, such as Hadoop's resource manager, Kubernetes, or you can directly use the inbuilt Spark simple manager. In all these cases, cluster manager will be responsible for giving the resources to you. And next one, worker node or executors. These are the actual executors or actual workers who will complete your task. It will be simply waiting for the task to be given and it will complete. Optionally, it will revert again to your driver program or it will just complete the task. So how it works? If you understand the flow by now itself, it will be very simple. You write your code. Basically, you will design your problem, how it has to be solved. Then this information like your problem statement, your different types of splitting the task, and you are connecting to the cluster manager, right? So how the configuration are made, all these things will be in the Spark context. And how are you planning to schedule your task? That will be given under the task scheduler. You have written everything. Now you will give this code to the driver. Now driver will talk to the cluster manager and it will get the necessary resources. And also now cluster manager will have the details about the executors and it will allocate the executors for you. Now you are given with different worker nodes. Next is driver will be sending the tasks which are designed in the driver program to the executors. And these executors will execute all at the same time, which is called parallel processing. After processing this data, based on your transformation or based on your need, either you can give back to the driver program or it will generate just output files. In this, we need to understand one key concept is RDD, Resilient Distributed Data Set. Let's understand one by one. Data set, obviously we are giving the data set. And what is distributed? Let's imagine you have 10 GB of data and you have 5 worker nodes. So obviously you will be giving only 2 GB of data for each worker node. You will not copy the data. You will split the data and give it to the each individual worker node as per the split. So here data is distributed, not copied. And resilient. You will be sharing this data or task to the different worker nodes, but there will be a metadata where you will have all the information in each mission, what task is being done and what are the expected results. For example, if any of the mission fails, by getting the data from the lineage is the kind of data where you will see all the information about your worker nodes, your tasks, and your split everything. So based on the lineage, you can recover from that. So it does not mean that if some machine fails, you have to travel from start to end again. You can start from where it stopped or where it broken. Next one is in memory. Since all the worker nodes will be processing your data in RAM itself, so it will be very faster when compared to the disk operations. But somebody might have the question like, what about the intermediate results? Not all the transformation will have the intermediate results. Details about the transformation we will be seeing in the coming sessions. But in simple word, for processing, you will have the RAM memory. Whereas if you want to save the intermediate results, you might use the storage memory or cache from the worker nodes. But again, it depends on the transformation that we want to perform. So by this time, we can clearly understand why Spark is fast. Rather than executing every data in a single mission, we are giving this data splits to the different missions and it has to be processed parallelly. So that's the reason Spark is very fast. And also, as we discussed, it keeps the data in your RAM instead of disk. So that's the reason the processing also very faster. And lazy evaluation. Basically, when you write your script, everything will not be computed, but only checked for the syntax, which means it will be executed only if it is necessary. Because of these reasons, we can understand Spark has a architecture of driver program, cluster manager, and worker nodes. These are the core components of the Spark architecture. We also have understood what is RDD, Resilient Distributed Data Set. So this is all about today's video. In today's video, we have seen the architecture of Spark. In coming videos, we will see the upcoming topics. Till then, always be a rainbow in others' cloud.